It's hard to believe that magma conduits may be forming beneath Mount Baker right now, and we still don't know if they're harmless pathways or the first steps towards an eruption.
Mount Baker volcano in northwestern Washington. Beautiful cone, but here under glacial ice there has been intense erosion to reveal older volcano stories, a volcano graveyard.
From the deep forests of Washington, where glacial rivers wind through valleys and clouds cling to rugged peaks, a subtle energy flickers beneath the surface. A pulse that few feel, but that shapes the destiny of millions. Here, cradled by evergreens and shrouded by nearly perpetual mist, rises Mount Baker, a sentinel of the Cascade Range, serene and snow-capped, its presence a constant on the horizon for those who call this land home. Yet, calm as it may appear, the story beneath Mount Baker is anything but still. Geologists have long known that these mountains, stretching from the Oregon wilds to the British Columbia border, are more than ancient relics. They are living volcanoes, restless, mysterious, and unpredictable. Every week, the United States Geological Survey issues its familiar refrain: all volcanoes in the Cascade Range of Washington and Oregon are at normal background activity levels. It is a phrase meant to reassure, but beneath the measured tones and technical language, discoveries continue to remind the region's residents that complacency is unwise. Much of Mount Baker's true nature is buried in data. The patient, relentless work of experts examining the smallest signals from within. What does it mean that modern instruments can now detect changes deep below this imposing peak, mapping the intricate paths that magma carves in the darkness? Is the volcano showing the first hints of reawakening? Or are these simply echoes of its ceaseless but routine behavior? Chapter 1. A mountain veiled in history. For centuries, Mount Baker has reigned as both guardian and enigma, a crown of perpetual snow, bearing silent witness to the cycles of nature and human life alike. Its brilliant white flanks, rising to over 10,700 feet, greet dawn with fiery alpine glow. And it stands sentinel over forests that have grown and fallen in its shadow. Native peoples have told stories of a powerful mountain spirit, and settlers came to respect its imposing calm, never quite forgetting the truth etched into its slopes. Mount Baker is alive. The mountain's volcanic history is written in black bands of lava, sheets of ash, and the warped valleys carved by ancient floods. Thousands of years ago, violent eruptions sent rivers of molten rock streaming down its sides, damming creeks and scattering forests, before settling into newly altered terrain. Centuries later, lesser events, a plume of ash here, a whisper of steam there, offered reminders that Mount Baker's silence is only temporary. Yet, in modern times, the mountain has built a reputation for serenity. Skiers flock to its snowy shoulders each winter. Hikers traverse its green meadows each summer. And for decades, those living nearby have gone about their lives without major interruption. The last significant eruption faded into memory generations ago. The 20th century passed with only minor steam and the occasional landslide, quickly fading from the collective consciousness. But history in the Cascades works on a longer clock. One marked by centuries, not decades. Moments of stillness do not erase the possibility of sudden change. The mountain's flanks, riddled with scars from past lahars, roaring cement-like floods of water, mud, and volcanic debris, bear silent testimony to what the future might hold. Mount Baker is, above all, persistent. A paradox of beauty and hidden risk. Its snow today covers the scars of yesteryear, just as the glacial rivers wind over ground long since remade by fire. The question that haunts those who study it: when will the next chapter begin? And when new signals emerge from volcano monitoring, are we reading the opening lines of a story? Chapter 2. The Watchers Below the Ice. While those below gaze up at Mount Baker's luminous summit, a network of silent watchers track the smallest tremor, the faintest exhalation of gas, and the softest rumble within the Earth's depths. Scientists at the USGS have transformed the mountain into a living laboratory, their tools as precise as they are invisible. It is a world of numbers and signals, a faint uptick here, a curious anomaly there. Yet within that complexity, patterns emerge that could one day foretell the next dramatic chapter of the mountain's story. Recent years have brought a hum of new focus. Seismometers feel for vibrations so delicate that a passing animal, a distant storm, or a shifting boulder could trigger a signal. Satellite measurements, peering through the ever-present clouds, search for envelopes of warmth, places where magma pressing upward may soften the ice above, warping Baker's frozen crown. Fumaroles in Sherman Crater, natural vents near the summit, are repeatedly surveyed by teams with multi-gas instruments, monitoring for the telltale rise in volcanic gases that might signal magma's upward journey. So far, however, the readings remain steady. The USGS, echoing its calm report, states, "All volcanoes in the Cascade Range are at normal background activity levels. There are no anomalies, no bursts of sulfur or carbon dioxide to send researchers scrambling. At the surface, the fumaroles issue constant, faint wisps, always present but never alarming. The work goes deeper still. Devices placed across the upper Middle Fork Nooksack drainage have noted continuing landslide activity, small debris flows cascading down steep ravines, sculpting the ever-changing face of the mountain. While dramatic in appearance, these slides are routine, the work of gravity and meltwater, not of catastrophic fire from below. Beneath this apparent calm, experts continually search the matrices of seismic data for patterns, a rhythmic pulse, faint but persistent, threading through the static. Is it the signal of a rising magma conduit quietly forming deep below Baker's base? Or just more of the restless chatter so common to volcanoes the world over? As scientists debate, one truth becomes clear. Watching Mount Baker is as much art as science, where interpretation and intuition intermingle with hard data. The mountain's inhabitants live with the knowledge that their peaceful routines may mask profound changes stirring in darkness, marked only by these delicate but telling hints from the depths. Chapter 3. Magma's Secret Pathways. Magma, molten rock held under enormous pressures, is the life force of every volcano, the fountainhead from which all eruptions spring. Hidden far beneath the crust, these fiery currents can sleep for decades, centuries, or even millennia before finding a path upward. When magma pathways form, they become secret doorways, routes connecting Baker's deep reserves to its summit vents and crater. The detection of such a pathway or conduit would be significant, but it is important to clarify. As of now, the USGS has not reported the recent detection of a new magma conduit beneath Mount Baker. Rather, the volcano is carefully watched for any evidence that magma may be moving or that changes in underground plumbing are occurring, events that, in the past, have heralded unrest. According to monitoring data, recent observations at Mount Baker, including multi-gas gas surveys, seismicity, and ground deformation studies, show no anomalies, and activity remains at background levels. However, the very process of monitoring for conduits and rising magma is a reminder. The architecture of the volcano evolves constantly, often quietly. Seismic arrays pick up clusters of tiny earthquakes, microscopic slips caused by stress in the mountain's interior, or by the movement of fluids. Modern GPS and tilt meters watch for swelling or subsidence across the mountain's surface, searching for the faintest swell that might betray magma's slow rise. For now, the data from Baker reflects an uneasy balance. There are no volcanic tremor swarms, no ground deformation, no vaporous blooms above the crater. The mountain sits, as it has for decades, in a state of poised potential. Normal, but only in relation to its own unpredictable past. The scientific reality: the presence of a pathway does not by itself mean an eruption is imminent. Such conduits may wax and wane, and throughout any volcano's lifespan, its magma plumbing shifts time and again. Some conduits become the avenue for dramatic events. Others seal and fade into obscurity, a record only in cooling stone. The question persists. If a new conduit forms at Baker, will it be the first step in a slow and silent reawakening, or just one of countless unseen changes inside the mountain's eternal darkness? Chapter 4. Shadows of Disaster: The Hazards Beneath Mount Baker. It is easy to gaze upon Baker's tranquil summit and forget the tumult possible beneath the ice. A future eruption, whether years or centuries away, may take many forms, each shaped by the intricate interplay of magma, rock, water, and ice. The catalogue of dangers is well known. Lava flows, rivers of molten rock, once tumbled through thick forests, incinerating everything in their path. Pyroclastic flows, seething clouds of ash and gas rolling at hurricane speeds, have been the doom of valleys unlucky enough to lie in their path, their touch asphyxiating and final. Tephra, the rain of pulverized stone and glass, can transform a bright day into darkness, drifting far from the crater to settle on fields, homes, and lakes. Yet perhaps the greatest hazard at Mount Baker is the lahar, a catastrophic cement-like flow of volcanic debris, ice, water, and mud. The mountain's glaciers are vast, its snowfields immense, raw material for disaster should eruption or heat cause a sudden melt. Past lahars have thundered without warning, swallowing rivers and choking valleys. Even without eruption, flank failures, massive collapses of the mountain's steep sides, can unleash debris flows. Communities downstream have mapped hazard zones and conduct preparedness drills. Emergency plans, sirens, and warning systems are in place, aiming to buy valuable seconds or minutes should an event begin. While no such unrest exists today, the potential is always present. Owing to the mountain's geological history, the next eruption of Mount Baker, whenever it happens, may produce lava flows, pyroclastic flows, tephra falls, lahars, and possibly flank failures. The volcanic hazards map is not filled with certainties, but with possibilities. Each scenario a product of the mountain's internal processes and its unique blend of snow, ice, and fire. Monitoring advances sharpen the question: is a new pattern a harbinger of lava, a trigger for slope collapse, or simply an unremarkable fluctuation in the mountain's natural rhythm? The answer, as always with volcanoes, will not be known until after the fact. Sometimes, sadly, only in hindsight. The memory of past disasters clings to the ravines and forests here, whispered in the silence between bird calls or the quiet drip of snowmelt. Should a surge come again, will we have the wisdom and tools to recognize it before the land is transformed once more? Chapter 5. The Science of Waiting. Beneath the technical prowess of modern volcano monitoring lies a profound paradox. Science can tell us much, and yet so little, about what comes next. The USGS warns that a new eruption at Mount Baker will most likely be preceded by detectable changes, subtle clues caught by instruments before any ash stains the snow or steam scars the sky. These clues could be seismic tremors, changes in the chemistry of volcanic gases, ground deformation, or warming of ice above unseen heat. But the shape and timing of those changes are stubbornly unpredictable. Patterns shift, data flickers, and the mountain keeps its secrets. Across the Cascades, every volcano is observed, analyzed, and compared. The refrain is familiar. All volcanoes in the Cascade Range of Oregon and Washington are at normal background activity levels. Calm today does not preclude violence tomorrow. This tension between vigilance and uncertainty is the constant companion of both scientists and those who live in the shadow of Mount Baker. The region's history is littered with quiet surprises and false alarms. Sometimes, swarms of earthquakes ripple through the crust, only to quell without consequence. At Mount Rainier to the south, for example, the largest earthquake swarm ever recorded at that volcano began on July 8, 2025, drawing increased scrutiny but, so far, no volcanic unrest. At Baker itself, there have been no such swarms, no abnormal gas emissions, no sudden changes to betray magma's upward journey. Every multi-gas survey at Sherman Crater returns the same verdict. No anomalies detected. The mountain broods quietly, in step with its neighbors across the range. Yet scientists remind us, not every detected pathway signals an eruption, and not every period of quiet is permanent. The ability to predict only improves as our data and understanding grow. The truth is that beneath the mountain, change is constant, often invisible, and sometimes only recognizable in retrospect. The more we learn, the more the Earth reveals its potential to surprise. The work goes on. Additional sensors are installed. More data is gathered. Hours are spent watching for the faint ripple or subtle shift. The ultimate question lingers. Will we see the next eruption coming? Or will it burst onto the scene with little warning? As unpredictable as the weather, and as inevitable as time. Chapter 6. A living landscape, people beneath Baker. While monitors watch. While monitors watch and scientists theorize, life at Mount Baker's feet ebbs and flows with the seasons, almost heedless of the risks hanging overhead. Towns nestle in the shadow of the mountain. Farmers till fields nourished by its volcanic soils, and forests march down the valleys, green and imposing. For many, the presence of the mountain is comforting, a landmark, a source of beauty and recreation.
Still, this region has adapted to disaster as part of daily life.
Emergency plans are drafted, evacuation routes marked, go bags packed and stowed in closets. School children learn to recognize warning sirens while their parents follow the latest news from the USGS. Every landslide, every flood, every strange thunderclap from the peaks above elicits a brief, collective moment of attention. A reminder that everyone lives with the volcano's potential. Chapter 7. A Constellation of Volcanoes. Mount Baker is not alone. Its story unfolds alongside the other giants of the Cascade Range. From the brooding slopes of Mount Rainier, now closely watched after its historic earthquake swarm, to the volcanic ridges of Oregon, the entire region lives with the uncertain rhythm of fire and silence. Each Cascade volcano is different, each with its own temperament and hazards. As scientists analyze the flood of data from their instruments, they find both unique patterns and underlying similarities, a testament to the restless crust beneath the Pacific Northwest. Here, magma is not always an isolated pocket, but can be interconnected. Its movements may quietly influence the entire arc, from Washington south into Oregon. This week, as in so many before, the official line holds. All volcanoes in the Cascade Range of Oregon and Washington remain at background levels. The exception, Mount Rainier, and its notable 2025 earthquake swarm draws scientific attention, but does not presently threaten eruption. The lesson is humility. Despite all our sensors and expanded scientific understanding, volcanic triggers and timelines remain elusive. The detection of new pathways or conduits, whether confirmed or hypothetical, is but one clue in a decades or centuries-long mystery. Volcanology is a science rich in questions. Each data point and anomaly brings us closer to understanding the immense, unseen engines at work beneath Washington and Oregon. Chapter 8. The Call of Uncertainty. So, what does it mean to search for or possibly detect signs of magma movement deep beneath Mount Baker? For scientists, it is a challenge and a source of wonder. Evidence that the volcano remains a living system, ever-changing, sometimes in ways that are invisible at the surface. For those who live downstream, it is a reminder that the story of the mountain is ongoing, and preparedness is a matter of both wisdom and necessity. The monitoring data today suggests calm. No surface anomalies have been detected, landslides are small and debris flows routine. Gas emissions at Sherman Crater remain within normal limits. Normal background activity, the refrain echoes, meant to reassure but also to remind. What is normal for a volcano is different for those who live in its shadow. The real story is not in dramatic headlines, but in the subtle, ceaseless cycles. The movement of molten rock, the shifting earth, the pulse felt only by those watching. Are we on the brink of a new awakening, or simply bearing witness to the indelible cycle of change and renewal that defines the Cascade volcanoes? Will science and observation allow us to recognize the next step before it comes, or only after the fact, when rivers run dark and the sky carries ash? The Cascade Range holds its secrets well. Every echo in the stone is an invitation to be aware, and a warning to remain humble before nature's scale. If the mystery of Mount Baker leaves you awed, unsettled, or simply full of questions, you are in good company. The story of Baker and all active volcanoes is an epic without an easy ending. The whisper of the mountain beneath snow and stone. And remember, every day is a new chapter, whether marked by calm or by change. The next act, whenever it comes, will be written not in sudden disaster, but in constant vigilance, unyielding curiosity, and the courage of those who live, work, and watch in the shadow of giants.